All right, so today we're looking at rational exponents. Rational exponents are just exponents that are essentially a fraction. This is nothing new in terms of what we have been doing. It's just a new way to write it. So every rational exponent can be written as a radical. Now, the way you write it doesn't matter, except the denominator of this exponent is the index of the radical, and the numerator of the exponent is the exponent you're raising it to. So both of these are representative of something we've done before. The numerator is raising it to a power, the denominator is the index. Now, you have two options here. You can either write the power on the inside of the radical and the radical on the outside, or you can write the power on the outside and the radical on the inside. Both of these are mathematically the same, and in some cases it might be easier to do one or the other. For example, we have 8 to the 5/3 power here. 8 to the 5/3 is the same thing as saying the cube root of 8 to the 5th. But there's an issue. 8 to the 5th is a really ugly number. That's a big number that we don't want to deal with. Instead, we could write this as the cube root of 8 to the 5th power. And now the cube root of 8 is 2, and then to the 5th power, 2 to the 5th power is 32. Much easier to manage. Same thing with our negative exponents, those are still applying. Now, the one thing you want to make sure you remember with negative exponents, it does not flip the exponent fraction. That will stay 3/4. What it will flip is the base. So this becomes 1 over 81 to the 3/4. And then we just need to figure out the best way to write it. We could do 1 over the cube root of 81 to the 4th, but 81 to the 4th is a really big number that we don't want to deal with. Instead, I would do 1 over the cube root of 81, or the 4th root of 81. Ooh, sorry about that. The 4th root of 81, saying 81, writing 18, and then raising it to the 3rd power. So that's going to give us 4th root of 81 is 3, so 3 cubed, and 3 cubed is 27. Okay, couple things to notice. That negative exponent, it just flipped the base, so it moved the base to the bottom. The exponent stayed the same. And when we used it, it didn't change the sign on our base. We still have a positive 81 there. Okay, a couple of mistakes that I see people make all the time. So for example, for this one, if we rewrite these as roots, this is going to be 1 over 256, and then the 4th, or to the 1/4, which would be 1 over the 4th root of 256, times, and then this one would be the square root of 256 cubed. And we could go through the process of simplifying those and all that, but these are still exponents, and we can still apply our exponent properties. We can say this is 256 to the negative 1/4 times 256 to the 3/2, and do our properties from exponents from last unit. We're multiplying common bases, so we can add the exponents. Negative 1/4 plus 3/2, that will be negative 1/4 plus 6/4, which is 5/4. So instead of doing two separate radicals that we're simplifying, we could just say this is 256 to the 5/4 power. Or in other words, the 4th root of 256 and then to the 5th power. So that's going to be 4 to the 5th power. And then 4 to the 5th power is going to be 1024. Okay. So any of our other property or power properties apply. So like for example, for this one, we can't multiply in the 3 to the base. This is 3 times 9 to the negative 3/2. And so we have a couple options. We can get common bases. So if we wanted to get common bases, we could say this is 3 times 3 squared to the negative 3/2 Power to a power lets us multiply, so 3 times 3 to the negative thirds. And then we're adding the exponent, so 3 to the negative second. Now we can simplify to make 1 over 3 squared, or 1 over 9. So that's if we wanted to get common bases. We could also just make a radical and simplify. So we have 3 times 1 over 9 to the 3 halves. So 3 times 1 over, and then the square root of 9 cubed. Square root of 9 is 3. 3 cubed is 27, so 3 times 1 over 27, which is 1 over 9. Both of them give us the same answer. It's up to you to choose which one you think is the best. But remember, if you're using common bases, you're using your exponent properties. You are adding the exponents when you're multiplying common bases, not multiplying the exponents. Okay, so take a second, pause the video, try this one on your own. When you unpause, I'll finish working it. All right, welcome back. So for this one, we have 16 over 81 to the 3/4. We can say this is the 4th root of 16 to the 3rd over the 4th root of 81 to the 3rd. 4th root of 16 is 2. 2 cubed is 8. 4th root of 81 is 3. 3 cubed is 27. So 8 over 27. All right, similar thing with this one, just like with our other exponent properties. When you have a negative exponent, it's going to flip the fraction. So this becomes 125 over 27 to the 2/3. So this is going to be the cube root of 125 squared over the cube root of 27 squared. Cube root of 125 is 5. 5 squared is 25. Cube root of 27 is 3. 3 squared is 9. Okay. Now, this one's a little bit different. In that other one where we had 3 times 9 to the power, we could get common bases. But we don't have a common base for 16 and 5. Instead, we're going to simplify this one and then just multiply our answer times 5. So this is 5 times 1 over 16 to the 3 halves. 5 times 1 over the square root of 16 cubed. Square root of 16 is 4. 4 cubed is 64. So 5 times 1 over 64. So 5 over 64. Okay, last one more I want you all to try. Pause the video, try it yourself. Okay, welcome back. This is another one where we could get common bases or we could simplify first. I'm at least going to do power to a power when we do power to a power multiplying. So this is negative 3 halves times 2. You can say this is negative 6 over 2, but no matter what, it simplifies down to negative 3. So this is 5 times 25 to the negative 3. And then if it was me, I would probably just get common bases. This is going to be 5 to the 1 times 5 squared to the negative 3rd. 5 to the 1 times 5 to the negative 6. And then we're adding the exponent, so 5 to the negative 5. No longer is this a problem that we have to get or even deal with the radical exponent. This becomes 1 over 5 to the 5th. And if it's on your green sheet, it's one you should simplify, which I can't remember off the top of my head. But if it is, this would be 1 over 3125. If it's not on your green sheet, which I don't remember for sure if it is, then 1 over 5 to the 5th is perfectly fine. Just depends on if this is on your green sheet. All right, that's it. If you have any questions, ask me or one of the other Algebra 2 teachers. You can try and send me an email. I'll try and respond. I will have tutorials on Monday before school if you have questions. Y'all have a great day.